My dear students, in the previous video I have solved some problems in the exercise given in the textbook. Now in this video I am going to introduce the section formula in the topic vector algebra. Section formula is used for finding the position vector of a point which divides the given line segment into the ratio m is to n internally or externally. That position vector of that point is called, defining the position vector of that point is section formula. Before going to that formula, I have to solve two more problems. First problem, find the DCs of the vector joining the point A and B. 2 points are given. Direction cosines, we have to find out the point joining A and B. The position of the point A is OA, that is I vector 2j plus 3k. Similarly, the position of the point B is minus 2, 1, minus 2, minus 1, minus 2, 1. That is minus I, minus 2j plus k. This is the position of the point B, OB. We have to find out the line joining from directed from A to B. That is AB. Line segment we want AB vector, that is position vector of B minus position vector of A. OB minus OA. AB is OB minus OA. OB is minus I minus 2j plus k minus OA. You multiply OA vector by minus, so you get minus I minus 2j minus into plus minus 3k. So you get minus 1 minus I minus 2i minus 2 minus 2 minus 4j minus 3 plus k minus 2k. See, this is AB vector. AB vector is minus 2i minus 4j the point position vector of the point A is 1 to minus 3. Therefore, you will get minus 3k. Position of the point A is minus 3k because the point A is 1 to minus 3. So minus 3k. So OB minus OA is minus of minus I minus into plus minus 2j minus into minus plus 3k. So 3k minus plus k, you will get 4k. Plus 3k plus k, you will get plus 4k. After finding the AB vector is OB vector, position of B minus position of A is OB minus OA, that is, this is the vector AB. Now we have to find out the direction cosines of this vector. For DC's direction cosines of AB, direction cosines of any vector is x by modulus of r, comma y by modulus of r, comma z by modulus of r. This is the formula for finding the direction cosines. So x is coefficient of I. That is mod of r is, this is A vector is r. You consider AB vector by r vector. So mod of r vector is root of minus 2 square plus minus 4 square plus 4 square because k is plus 4. So this is 16, 4 square 16 plus 16 plus 4, 32 to 36. 16 plus 16, 32 plus 4 is 36, square root of 36 is 6. So modulus of r is 6. Therefore, x is minus 2. So minus 2 by mod r is 6. And y is minus 4. Minus 4 by modulus of r is 6. Z is plus 4 by modulus of r is 6. So this is or minus 2 by 6, minus 4 by 6, comma 4 by 6. It can be simplified. You will get minus 1 by 3, comma minus 2 by 3, comma plus 2 by 3. These are the direction cosines of the given vector line joining the point A and B. Directed from A to B. So after finding the AB vector, using this idea, we are finding the DCs. That's all about the problem. And another problem. Find the unit vector acting along the direction of the line joining the points P and Q. So that is another problem. Find the unit vector acting along the line joining the points P 1, 2, 3 and Q 4, 5, 6 and Q 4, 5, 6. Find the unit vector acting along the line joining the points P and Q. That is, you have to find out the vector PQ. This is Q and this is P. The line joining the points P and Q. P is 1, 2, 3 and Q is 4, 5, 6, 4, 5, 6. After finding the vector PQ, you have to find out the unit vector acting along the line PQ. So, position vector of P. Another problem. Position vector of P is OP vector. Position vector of P is OP vector. OP vector is I plus 2j plus 3k. I plus 2j plus 3k. Similarly, position vector of Q. Position vector of Q is OQ. That is 4i plus 5j plus 6k. 4i plus 5j plus 6k. This is position vector of OQ. Now we want PQ. PQ is OQ minus OP. Same idea. Now we have to find out the vector PQ first, and then you have to convert that the vector unit vector acting on the line PQ. So we have to first find out PQ vector is position vector of Q minus position vector of P. OQ minus OP. OQ is 4i plus 5j plus 6k minus OP. Multiplying OP by minus I minus 2j plus into minus 3k. So you get 4 minus I is 3i. Now PQ vector is four I minus I is 3i, 5j minus 2j is plus 3j, 6k minus 3k is plus 3k. So PQ vector is 3 times of I plus j plus k. Taking the common 3 out of all these 3 components, I get 3 into I plus j plus vector k vector. So now we have to find out the unit vector in the direction of PQ is unit vector in the direction of PQ is PQ cap. That is by formula PQ vector by mod of PQ vector. That is the formula. Unit vector acting on the direction of PQ is PQ cap. That is A vector by mod A vector. So you know PQ vector is 3 times of I plus j plus k by mod PQ is, you know, here PQ is 3 times of I plus j vector plus k vector. You know PQ vector is 3 times of I plus j plus k. This is 3 times of mod of PQ is modulus of 3. You can take common. You will get mod of 1 square mod of I j plus k. 1 square plus 1 square plus 1 square. This is I plus j plus k, which square is mod 1 square plus 1 square plus 1 square. That is equal to 3 root 3. So mod of PQ is 3 root 3. So 3 cancel. Therefore, the required unit vector PQ is equal to 1 by 3 cancel 1 by root 3 into I plus j plus k, or otherwise you can write it as 1 by root 3i plus 1 by root 3 into j plus 1 by root 3 into k cap. Like that, we can convert the unit vector joining the points P and Q. Next, unit vector acting on the line joining P and Q is this. And next, one more problem. Show that the vector I plus j plus k show that the vector I plus j plus k vector, this vector is equally inclined and equally inclined. The vector is equally inclined to the axis, equally inclined to the coordinate axis, to the axis OX, OY and OZ. This vector I vector plus j vector plus k vector is equally inclined, equal angles inclined with the axis OX, OY and OZ. Equally inclined means x, the vector I vector plus j vector k vector is inclining angles with the coordinate axis OX, OY and OZ are one and the same angle, equal angle I mean. That is alpha, the vector I plus j plus k makes an angle with the x-axis is alpha and the vector y-axis is beta and angle with the z-axis is gamma, you know. But these alpha, beta and gamma are equal for this vector. The vector equally inclined with the coordinate axis. That is alpha, beta and gamma are equal, we have to prove. See, you consider the vector, given vector by R. R vector is I plus j plus k. The xi plus yj plus zk, I mean, x coordinate is 1, y is 1, z is also 1. Components of ij are 1. Mod of R is root of 1 square plus 1 square plus 1 square, that is equal to root 3. So, you know the angles inclined by the vector with the coordinate axis are alpha, beta and gamma. So, cos alpha by formula, you know, cos alpha equal to x by mod r, you know, direction cosine is nothing but cos alpha is x by mod r. X is 1, I coordinate is 1, by modulus of r is root 3. So, cos alpha is root 3, from this you get cos alpha equal to cos inverse of 1 by root 3. Cos alpha is 1 by root 3, alpha is equal to cos inverse of 1 by root 3. Similarly, cos beta is y by mod r, modulus of r. Y is 1 by root 3. Therefore, cos beta is 1 by root 3, so beta equal to cos inverse of 1 by root 3. Similarly, cos gamma equal to z by mod r. That is, z is also 1 by root 3. Z is also 1. K coordinate z is 1 by root 3. So, gamma equal to cos inverse of 1 by root 3. So, alpha, beta, gamma are equal. All are cos inverse of 1 by root 3. Equal angle. Therefore, alpha equal to beta equal to gamma equal to all the three angles are equal to cos inverse of 1 by root 3. Cos inverse of 1 by root 3. Therefore, alpha, beta, gamma are equal. Therefore, the given vector is equally inclined with the same angle with the coordinate axis. That's all about the problem. So, this vector inclined equal angles with the axis. That's all about this problem. Next, I am going to introduce section formula. Section formula, I already told you, the position vector of a point, line segment joining the 2 points. The point divides the line segment in the ratio m:n internally. If it is so, what is the position vector of the point? We have to find by section formula. So section formula is position vector of a point joining the line segment C. Let R be the point. Divide the line segment. Divide the line joining the points. Dividing the line. Let R be the point. Divide the line joining the points P and Q. Let R be the point. Divide the line joining the point P and Q internally. Internally in the ratio m:n. If it is so, find the position of the point R. Or we have to find out. See, this is the point Q and this is the point P. O is the origin with respect to the point origin O. OP is vector A. OQ is vector B. And R divides the line segment PQ in the ratio m:n. Okay, we have to find out the position vector of the point R or we have to find out. R is the point divides the line segment PQ in the ratio m:n internally. Internally, P, in between P and Q, R divides internal division in the ratio m:n. Therefore, we have to find out the position vector of the point OR. Let us consider the R vector. Position vector of the OR is R vector. We know that R divides PQ in the ratio m:n. R divides PQ in the ratio m:n internally. Is it not? Already given in the problem, therefore you need not write once again. R divides PQ internally in the ratio m:n, therefore PR by RQ. PR by RQ. PR vector by RQ vector is equal to m by n. PR by RQ equal to m by n. Okay, this is by cross multiplication. N into PR equal to m into PQ. RQ, sorry. M into PR vector equal to m into RQ. You know PR is OR minus OP equal to m into RQ is OQ minus OR. N into OR, you know, OR is R vector with respect to origin O. OR is R vector, OP is A vector equal to m into OQ is B vector. OQ is B vector. Position vector of B minus OR is R vector. Now use multiplying m into R minus n into A equal to m into B minus m into R. You bring, already you keep mb on the right hand side, you take that na to the left hand side, it is plus na. If you take minus na to the right hand side, it is plus na, mb plus na. Here you have, if you bring mr to the right hand side, mr plus already nr is here. So if you take r common, R vector common, you will get m plus n equal to MB plus NA. So R vector is MB vector plus NA vector divided by M plus N. This is the question under the point R, which divides PQ internally in the ratio M is to N. R vector equal to MB plus NA by M plus N. That is internal division. Okay? I will stop here. The external division we will see in the next video. Thank you.